the same way. We must hydrotreat the product naphtha from both alternatives. Then we have a choice. Do we have to only hydrotreat the gas oil or hydrocrack it into even more? So that's why you have an alternative. So if I were to go back, which I want to do it, I were to go back to here. This scheme here, I know it's kind of, we try to make it. The refined thing has a block flow diagram that's busy. You'll spend an hour looking at it. This is the opposite. This one is oversimplification to cover all cases. So you have to relate this diagram with that matrix to kind of understand it. So resid upgrading here could be vis breaking, in which case really we don't have a naphtha hydrotreater. But when it's delayed coker or ebulated bed, then we will have a naphtha hydrotreater on the naphtha portion, and then if it's coking or the ebulated bed, we have a stream going here. This could be either a gas oil hydrotreating or a gas oil hydrocracking. Okay? The line is not shown here because it doesn't cover all cases. In the vis breaker case, we don't have. So this is a bit oversimplification, but you kind of have to interpret that diagram with this. So I could have shown a different sketch for each one of these cases. If I did, that's why I tried to show it there. Okay. But that's what's happening. So that diagram is kind of an umbrella, and then you have to interpret it based on the X's in here. So on the delayed coking, there's really a line from the bottom part that says resid upgrading to the naphtha hydrotreater, another line to either to the hydroprocessing unit, which could be a hydrotreater, gas oil hydrotreater, or hydrocracker, different units. In which case, one is more severe than the other, hydrocracker. Okay. Now, these are the cases. Okay. This is another slide. The reason I'm showing it here is kind of to address the question of how the hydrogen is produced. In all cases, except vis breaker case. The vis breaker case has no hydrotreatment whatsoever. All of the other cases, there's some sort of a hydrogen consuming unit. Okay? Now, in all cases, in the refined model, when we run it, we have really produce hydrogen by steam methane reforming, because that's like a base. But if you look up case 2, for example, I don't show for GHC only a steam methane reforming. The reason I didn't show it because I ran it, but the economics wasn't there. So it was considered, but I tried to kind of boil it down to minimum cases. So steam methane reforming was considered in every case, and it's represented in most cases. Like if you go from the bottom, 8A is this case with steam methane reforming. 8B is the same case with hydrogen by gasification. In this case here, there's 6A, 6B, 6C is the same coker, but it's coker with gas oil hydrocracking, but the hydrogen is produced by steam methane reforming. Then the same thing is happening, the same operation, so the yield will be the same exactly as far, well, not quite exactly actually. In here, the yield will be a bit different. I don't know why. In the coker, it will produce the hydrogen by gasification, and in here we produce hydrogen plus power. So the yield will be identical for all these three, right? Because in here we use